All right, so I see some of you guys joining the stream. You're welcome back once again to this live section. So in today's lecture, we are going to continue to our topic that we started, our course that we started yesterday on introduction to business statistics. So today we are continuing and we are looking at the levels of measurement as the latter part of the introduction to the business statistics. So if you are live and you have joined us, please make sure to like this video, share it out with your friends so that inform others that we are live so that they also join us so they all learn together in that case. So keep on sharing this video and then invite others to join us in that case. So let's jump in right away as we continue with our discussion on introduction to business statistics. And today we are looking at the levels of measurement. So please share this video and make sure to like us so that others can also join us in that case. Others can also join us in that case. All right, so let's continue. So yesterday we started with a concept about introduction to statistics, and then we talk about a brief history about how statistics as an academic discipline emerges, and we said that statistics as academic discipline emerges from two paths, and we trace it from the official statistics, that's from the government part, and also where we trace it from the academic, where it is being used by or is being studied by universities and most educations or mostly our education sectors that we have around the world. So we also continue also to look at the definition of statistics, and we said that the definition of statistics can be defined from two perspectives. You have the plural form and you have the singular form. We define these two perspectives, and then also we also went along to also to define certain key functions of statistics, such as numeric data, collection of data. I mean, this process that we use to define statistics, I mean, we went through, and then also we also went along also to discuss the reason why we need to study statistics. And I think we also define certain terms in relation to statistics. So today we are continuing from the levels of measurement that data need to be engaged. So actually we have what? Four levels of, so before, when we talk about the levels of measurement, we are talking about how data is being measured through observation, how you measure data through observation. Is that okay? So when you are talking about levels of measurement, you are talking about what? Observation of the how you measure or you assign numbers to the data that you want to what? Measure. Is that okay? So when it comes to the levels of measurement, actually we said data is actually a fact or figures that we collect, we present and summarize in a way that we can communicate for and also interpret and assign meaning to that. So when it comes to levels or when it comes to measurement of data, we are talking about what? Assign of numbers to what? The data you collected. And how do you assign numbers to data you collected? So when it comes to the levels of measurement, we have four key levels of measurement or four methods of measuring what? Data. We have four levels of measuring data. We have one, the nominal level of measuring data. Two, we have the ordinary method of measuring data, ordinary scale. We also have the interval, and we also have what? The ratio. So we are going to go through how we measure these data from this set of what? Data. So let's take it from here. Measurement of data. Measurement of data. So let's take it from here. Measurement of data. So when it comes to measuring data, as I've already indicated, we have four steps or four methods for measuring what? Data. We have the nominal level. What is the nominal level of measuring data is saying? When it comes to the nominal level of measuring data, it is a method that measure data or in which data are measured through which data can be counted or classified. So when you're talking about nominal level of measuring data, you are saying that here data can be what? Classified or counted. When it comes to the nominal level of measuring data, here you are saying that data can be classified or what? Or counted. I hope that's so. Here, when it comes to the nominal level, we are talking about what? Specific group of data within which we can measure data. For example, when we take gender, male and female, we realize that male cannot be part of what? Female, at the same time can be part of what? Male. So gender becomes what? A nominal what? Level of data. So when it comes to a nominal level, we are talking about what? Group membership. Is that okay? We are talking about group membership, where we have what? Data within a particular what? Group. Where we have data within a particular what? Group. when you talk about, uh, let's say we have toffees. It's a data that you want to measure. When you bring in biscuits, can biscuits be part of toffees? No, because biscuits is a different data set altogether. So realize that when we're talking about the nominal level of measurement, we are talking about what? Group membership. We are talking about what? Ownership within certain what? Group. So that is the nominal level of what? Measuring data. You are talking about ownership. And in that, data can only, when it comes to the normal level of data, when it comes to the nominal level of measuring data, data within those elements can only be found within one group. So we are talking about what? Membership of data. Is that okay? So under that, when it comes to measuring data, I say that one of the properties of the measuring of nominal data is that data are mutually what? Exclusive, meaning that one set of elements or one set of data can only be part within what? One group, and cannot be part in other group. Is that okay? So when you take, for example, our religious belief systems that we have here, we have Christians, we have Muslims, we have tradition, we have other religions that exist. Okay, you realize that if you are in, if you are a Christian, you realize that you cannot be what? Muslim. Likewise, if you are a Muslim, you can also be what? In Christian. So all things being equal, that is the membership we are talking about, and that's what nominal level measure that kind of data. So when you're talking about data and the nominal level, we're talking about what? Membership or a group. Is that okay? So let's take note of that. And the next one, so as we have already defined, there are four levels of nominal level. We have the ordinary level, we have the interval, and then we have the ratio. So the nominal level, we are saying that nominal level of measurement, the observation can only be classified or counted. I think we have spoken about this. And then the nominal level of scale defines specific categories by name, number, or symbol. So the nominal scale indicates a group membership. This was what I was talking about. So there is no particular order to the level. So because of that, because members can only be within one group, we cannot have an order that we can what? Rank what? Data. Because let's take grading system. Let's say first class. Let's say we are all in first class, or we have data A in first class and data B in first class. One thing here is that because they are all in the same class, we don't know how we can rank them. Whether, let's say, data A is having higher mark to rank first class, or data B is also having lower marks to also to rank, let's say, in terms of marks. That's what I'm saying. Let's say we have data A having, let's say, CW of, let's say, or first class with a number of, let's say 75, and let's say B is also having a class of with a number of, let's say 72. Realize that though they are all within the same class, but then because the number differ when it comes to the nominal level, it doesn't take into account the number that differs between the two, and therefore data cannot be what? Rank or what? Ordered. Is that okay? So that is the nominal level. So that's one shortage or one limitation about nominal level. We cannot what? Compare data elements from one level as against what? Another. So that is the nominal level for data. So we are saying that this is the weakest scale of what? Measuring data. So in the nominal level, as you have said, so these are some of the properties of the nominal scale. We are saying that data categories are mutually exclusive, means that an individual can belong to only what? One category. And then also, there is no logical order, because data within this what? Particular level of measuring, this particular level of measuring data doesn't take into account the number that exists between one data set as against what? Another. So there is no what? Logical order. We just take into account the level or characteristics that exist between what? These level of data, or these what? Elements of data that exist between these set of data. So just take into account the features that exist between one data and what? Another, or that's common to one data and what? Another. That's what the nominal level does. Is that okay? So because of that, we can what? Rank or have a logical arrangement of what? Data sets. Let's say this is the highest, this medium, this is what? The lowest form in terms of the data set. So that is the nominal level. Now, these are some of the examples. As I said, gender is one. You can also talk about colors. Actually, say classification of colors of candies could also be brown, yellow. So if candy, that particular color is not part of the candy, then it cannot be part of it. Gender is also another part. Then people also categorize on the basis of marital status. single, married, divorced, and widowed. So if you are part of this, you are within one group or one class. Is that okay? And then you also have numbers of automobiles, license plates. These are all examples of nominal data, and number of football jerseys, and so on. So let's take note of that. When it comes to the ordinary level, actually the ordinary level incorporates all the features, all the characteristics of the nominal level, with the exception that because with the nominal level, where data cannot be ranked or ordered, that is what the ordinary level actually solve. There is a problem that the ordinary level actually solve. With the ordinary level, it takes into account the limitation of what, where data cannot be ranked in the nominal level of measurement of what data. I hope you are following. So with the ordinary level of measuring data, the only feature that adds up is here data can be ranked or what, ordered from, let's say, high to low or low to what, high. For example, taking the grading system of what, for students, you can clearly see that we have what, we have excellent, we have very good, we have good, and those kind of stuff. These are what we're talking about because that was the limitation that the nominal level couldn't able to measure. So with the ordinary level is able to take data into account by comparing data sets from one point towards another. So there is a ranking, can rank data. So here it takes into account greater than or less than or equal to, and these are the relevant aspects of an ordinary level of measuring data. Is that okay? And then we are saying that because of that, we can talk about, for example, we can talk about uh, a professor or a list of students rating finance professor. I mean, table below lists the students rating of what, finance professor. This is what the rate them. We have superior, we have good, we have average, we have poor. So these were the ratings. So as I've already indicated, with the ordinary level, we can what, rank what, data. We can rank data, or we can compare one data as against what, another. But that is not the case of what, the nominal level of measurement. So let's take note of that. Let's take note of that. Let's take note of that. So that is the ordinary. But the one advantage here is that when it comes to the ordinary level, let's say we are talking about class system, first class, second class. Let's say first class, a student is, let's say, first class. Let me use an example here. Let's say a student is in first class, and let's say this is a student A, is in first class, okay, and he's having, let's say, a CW of, let's say, 75. Is that okay? And these students, let's say, is the same first class, also in first class, but having what, a CW of, let's say, 72. One limitation about the ordinary level here is that ordinary level also don't take into account the magnitude between one set of data as against what, another. Doesn't take into account the magnitude or the distance between one set of data and as compared to what, another. It just take into account their class system that they have. So let's say because A is in first class, fine. B was in first. Let's say B was in second class. Let's say B was in second. Let's say 65. All that ordinary level will do here is that to measure data based on what, their ranking. So because A is in first class, it's going to rank as A, and we also have system of grades used in military. We have for sergeant and corporal. So these are, I mean, titles that are arranged in order or rank. And you also have grade A, B, C, and other issues. So when it comes to the ordinary level, there is ranking. But then one advantage I've already indicated here is that if we are talking about the number that exists between one set of data and another, it doesn't take into account the distance between one set of data and what another. I mean, the magnitude between one set of data and another. Ordinary level of measurement doesn't take into account when it comes to the measurement of a set of data, and that is what the interval measurement of data takes into account. So these are some of the properties, as I've already indicated. With the nominal level, we said data categories are mutually exclusive. So here, it also have that same properties with the ordinary level too. Data categories have a logical order because we can rank data from high towards low. And then also data categories are scaled according to the amount of particular categories that they possess. That is from the nominal level of data. And that is what ordinary level also would have. But then the only additional property that I add up is that because there's limitation of the nominal level was I cannot rank data or cannot logically rank data. That is what the ordinary level brings in or solved. Here, when it comes to the ordinary level of measurement of data, data can be ranked or what logically what arranged. Is that okay? Or compare from one set of data to what another. And that was the one property that I add up, that data categories have a logical what order. So that is one thing that you also need to know. So when it comes to the interval, as I was saying, the limitation about the ordinary level that the interval solve here is that it doesn't take into account the distance between one set of data and what another. So there is no, because when it comes to ordinary, there is no specific distance that exists, or there's really measurement of distance that exists between one set of data and another. That is what the interval scale comes into measure. So it incorporates all the properties of the nominal and the interval with the additional property where it takes into account the distance between one set of data and what another. Is that okay? So that's what the interval scale incorporates all the features of the ordinary and hence the nominal scale. An additional feature that the distance between the levels of scale can be what specified. Is that okay? So that's what I'm actually talking about. Okay, so it incorporates all features of what we have discussed so far, in addition to the distance between levels of data, which can be what specified. Is that okay? Right. So for example, we can talk about, so let's see some of this. We can talk about what temperature. Let's say we have 60, sorry, I'm coming. So let's say we have 60 to let's say 70 as was indicated as an example here. Realize that the distance between 60 and 70 is what 10. And one key disadvantage about the interval scale here is that because actually it can assume any distance for a particular result, that becomes a limitation. And as such, there is no starting point and then the ending point of what between two sets of data. When it comes to the interval scale, the idea here is that one limitation is that actually it includes all the properties that we have discussed so far, the nominal and then the ordinary. But then one advantage that is saw from the ordinary is that because the ordinary doesn't talk about the distance between one set of data and another, that is what the interval scale talks about. But the limitation about the interval scale here is that because it can assume any set of data and can measure a particular result. For example, we know 60 and 70, the distance between these temperatures is what 10. We can also say that 20 and 30, the same distance is what 10. And as such, because of these features about interval scale, there is no starting point and there is no what ending point. That's why we can talk about a limitation. Because before you can measure any set of data between distance, at least we have what the starting point and then the ending point that we can measure those set of data. But here is the case that you just take any distance because the difference going to, for example, because what we have, the difference going to be 10, you just take any distance and measures it. And that becomes what limitation. So here there is no starting point because for us to measure any particular set of data, it should start from 0 and end to a particular number that they want to take into account. But because here it can assume any range of what distance, and I don't know the result is going to be the same. And aside that becomes a limitation. And aside there is no what we call we don't have what the starting point that should have been 0 and end to another. So what I'm trying to tell you is that when it comes to the interval, there is no 0 point that we can locate between what set of data. Is that okay? So let's say I want to count the number of citizens from Kumasi to, let's say, Accra. Fine, I want to start from Kumasi. You ask yourself, which particular place in Kumasi should I start the counting? I mean, I can start from anywhere, right? And count till I reach to Accra. And because of that is kind of limitation of the interval scale, there is no starting point of what measuring data. And as such, it doesn't take into account what the starting point, which is what should be what the zero. So I'm trying to say here is that we don't have what a meaningful zero when it comes to measuring of data using the interval scale, but all other features hold true. For example, intelligent quotient. Let's say we have what 130 and then 140. It just starts from any values. The difference is 10, right? Then you're also saying that it's the same thing as what 80 to what 90, and so the difference is 10. At least you'd have said that okay, you want to find the difference of 10, it should have been 0 to, let's say, what 10. But then that's not what he's saying. That becomes a limitation to what the interval scale of measuring of what data. So that is what we also need to take into account when it comes to the interval scale of measuring set of what data. So let's take note of that. So that becomes a limitation, and that is what the next scale we want to discuss solve. Is that okay? So when it comes to the interval scale, we have other examples that we can talk about. So as I've said, the properties always remain the same. Data categories are mutually exclusive. Then data categories have a logical order. Data categories are scaled according to the amount of particular characteristics they possess. And then also, this is what I was trying to talk about. I think this one, the last point, that the interval scale requires a 0 point, but the 0 point is completely arbitrary. What does it mean? That is, we do not know where the 0 is located. That's what the example I was trying to say, that we wanted to count the number of citizens from Kumasi to Accra. And then let's say I want to begin from Kumasi, but I don't know the actual area or the actual town that I should start the counting in Kumasi. Is that okay? And that becomes what? A problem. So here means that here the 0, we do not know where to locate the 0, or we know where to locate the starting point to count these citizens from Kumasi to what? Accra. And that becomes a problem. So in that, it is not important which measure is declared to be 0. I mean, when you are measuring that set of data, you can choose any point to be the starting point, because they're going to get the same result. Here we are saying that it's not important, and hence we do not have what a true 0 or what a meaningful what 0. That's what becomes a limitation of the interval scale, and that is what the next scale we're going to discuss, or the next level of measurement scale, which is the ratio scale, solve that. So the ratio scale actually is the highest level of measurement, and it incorporates all the properties or all the features we have talked about from the nominal, ordinary, and then the interval. And additionally, there is what we call a meaningful 0, the limitation of the interval scale. That is what the ratio scale solve. For example, let's use, for example, money as a ratio data. If you have 0, let me have something here. If you have $0, if you have $0, that means that what is the meaning of the $0? It means that you have what? Nothing. You have no money on yourself. You have nothing, isn't so? But then if you have, let's say, $100, it means that you have something on you, isn't so? Yes, you have money on yourself. So here, when it comes to the ratio scale, we can actually know the starting point of data and then the ending point of what? Data. We can know the starting point of data and then the ending point of data. And as such, ratio scale 0 is what? A meaningful what? Set of data. Because we know the starting point and we know what? The ending point. Is that okay? So 0 has a meaning when it comes to what? Ratio scale. But when it comes to interval scale, there is no what? Meaningful 0. Or 0 is not true. We don't have a true what? 0 as a set of data, or as a starting point of what? A data. Is that okay? But when it comes to ratio scale, there is what? A meaningful 0. Means that if you have $0, means you have nothing on your own. But if you have $100, you have what? Something on you. So that is what actually ratio scale come to solve. So we are saying that ratio scale is the highest level of measurement, and then the ratio level of measurement has all the characteristics of interval level, but in addition, the 0 is a meaningful, and the ratio between two numbers is also what? Meaningful. Means that if you have $0 to, let's say, $100. So if you have $0, means that you have nothing on you. But if you have what, $100, means you have something on you. So it means that zero can be interpreted that there is a meaning behind what the zero, isn't so? So here means that from the 0 to 100, the interval between 0 to 100 are meaningful. We have meanings assigned to what this set of data. So money become one set of what a ratio, example of what a ratio, what measure of scale of a data. Is that okay? We can also talk about time. Let's say it is 0 o'clock, and let's say towards, let's say 1 o'clock, let's say AM. Means that here the time is at rest. When it gets to 1, means that it's what 1 what AM. We have meaning assigned to it. It has clock 1 AM, and there is meaning behind based on the environment or based on what the weather. You can determine that this is the morning, this is the afternoon, or whatever that you want to talk about. Is that okay? So time is also another example of a ratio scale. I mean, we have a lot of examples. So examples, we can talk about wages. That's where in the form of payment money. We have what production. We have production of units. We also have weight. We have height. All these things are ratio scales. Is that okay? So when we talk about, let's say, the weight, take into account the weighing scale. If you have the weighing scale, nothing is on the weighing scale, means that at that point, the weight is at what? Zero, because there's absence of weight on that machine. But when we have something placed on it, then we can determine the weight of something. So mean that when there's nothing placed on the weighing scale or that machine, it is at zero. So meaning that there's absence of weight on it. But when we have something placed on it, means that there is a weight on it. So we can assign meaning between the zero at the 0 point, and then where we have what something placed on it at a particular auto point. So mean that between 0 and what another number, they have what a meaningful what explanation behind set of what data. That's why he's saying that 0 point is meaningful, and also the ratio between two sets of numbers also what meaningful. So that explains what I'm trying to talk about. So money is also a good illustration that we can talk about here. So these are some of the examples that we can talk about when it comes to the ratio scale in that case. So here, all the properties of that of the ordinary, the nominal, and then the interval ratio scale have all of them. But the ratio scale is the highest level of measurement. So data categories are mutually exclusive and exhaustive. Because if you have from 0 to 100, means that you have all the set of data inclusive. That's why you say that it's exhaustive. So you have all the data sets what as inclusive as part of what measuring that particular set of data. That's under the ratio scale. Also, data categories have a logical order. That you can rank data from high to low or low to high, whatever categories or whatever rank you want to assign to this set of data. We also have data scale as scale according to that's the nominal property. That's also ratio also have the same. There's also equal difference in characteristics that represent by equal difference in numbers and assigned to categories. I mean, these are number of properties of what ratio scale. So all that you need to know here, there is a linkage from the nominal level to ordinary to interval and ratio. Means that all the properties under nominal scale, interval, ordinary scale houses all the properties to also to include what ranking or ordering of what numbers where you have less than, greater than, or equal to. When it comes to the interval have all the properties of nominal, have the properties of the ordinary, and includes what the distance between two sorts of data. Is that they measure the distance between two specific sets of data. And when it comes to the ratio, it includes all the properties of what the nominal, the properties of the ordinary, the properties of the interval, to also to include a meaningful zero in which the ratio between two sets of data also what meaningful. So that is what the whole levels of measurement that we're trying to talk about is. So basically, in summary, we are saying that we have 4 levels of measuring data. We have the nominal level, we have the ordinary level, we have the interval level, and we have what the ratio level. The ordinary level, we are talking about what membership or group membership. We are talking about where set of data can be classified or counted. When it comes to the ordinary, we are talking about ranking of set of what data. When it comes to the interval, you're talking about the distance that is between two sets of data. And when you're talking about the ratio, you're talking about what? We are saying that this is the highest level of measurement in which 0 and two sets of what numbers between two ratio sets of numbers are what meaningful. And that's what we are talking about when it comes to the ratio scale. And this is why we bring an end to our today's discussion. So thanks for joining. Bye bye.